Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 23 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 889. Construct binary tree from pre-order and post-order traversal. Okay, so first thing that you should know what is pre-order traversal and what is post-order traversal. Okay. So pre-order traversal, we visit the node in this order. First root, okay. Then we go to the left. Then we go to the right. Okay. So this is nothing but my pre-order traversal. Okay. This is pre-order. Okay. And then what is post-order traversal? In post-order traversal, we first visit left. Okay. Then we visit right. And then after that, visit root. Okay, this is for post order, and there is one more traversal like in order traversal. Okay, so in order traversal, first we move to the left, and then we cover the root, and then after that we go to the right. Okay, so these are the three types of traversals in trees. Okay, pre-order starting from root and then left side and then right side. Okay, in order left. Okay, so in order first left then root and then right. Okay, and in post first left right and then root. Okay, so this is the order, right? So in this problem we have given two integer arrays, pre-order and post-order, where pre-order is the pre-order traversal of a binary tree of distinct values. Okay, all the values are distinct, and post-order is the post-order traversal of the same tree. We have to reconstruct and return the binary tree. Okay, and if there exist multiple answers, all right, then you can return any of them. All right. Okay, so this is the problem statement. Okay, so now see this example number one. All right, so this is pre-order traversal. Okay, so this is my pre-order, right? Definition. So first one is the root. Okay, then two. Okay, we move to the left. Okay, then for this left subtree, this is my root. Okay, so here I am writing 2, and for this root, this is the left, I am writing this left, and this is the right. Okay, done. And then after that, this root done, this complete left done. Now we move to this right. So for this right, this is my root. Okay, so I'm writing 3, then this left, and then this right. Okay, so this is nothing but my pre-order of this one. Okay, now if you see the post order of this one, so in the post order first we go to the left. Okay, so 1 2 4. Okay, so this is the leftmost node, right? For this there are no other children, right? So 4 I'm going to write. Okay, then 4 is done. Okay, we cover left, now we have to cover right. So 4's right is this 5, so I'm going to write 5 here. And then 4 and 5, what is the root for this 4 and 5? This 3, so 2 is the root. Okay, so I'm writing 2. Okay, so now this complete left is done. This complete left is done. Now I'm going to cover right. Okay, this right. So for this right, first for this tree, first we have to write left. So left is 6, then right is 7, and then this is root. Okay, 3, and then in the end, now left is done, right? This right is done. Okay, now left is root, so now I'm writing root. Okay, so this is just a traverse. Okay, this is just I have showed you about how we write pre-order and post-order. Okay, now we have to return the binary tree. Okay, so 1 this, then 2 3. Okay, then 4 5 6 7. Okay, so there are multiple answers, so we can return any of them. Okay, so this is what we need to do, right? Okay, so now how I'm going to solve this problem? Okay, so this is my pre-order given to us, right? Pre-order. So here let me write pre-order. Okay, pre-order is like this: 1 2 4 5 3 6 and 7. Okay, so this is nothing but my pre-order, and my post order is like this. Post order, first we have 4, then we have 5, then we have 2, then we have 6, then we have 7, then we have 3, and then we have 1. Okay, let me give the indexing as well. 0 1 2 3 4 5 and 6. Okay, so now see carefully how I'm going to construct the tree. Okay, construct a binary tree for this one. Okay, so pre-order, okay, it is starting from root. Okay, so right now let's say I am at this particular index. Let me use this pencil. Okay, so let me say that I am here. Okay, and in the post order, let's say I am here at this particular index P. Okay, P is the indexing for this post and I is the indexing for this pre. Okay, let's say. All right, so now pre is starting from root. Okay, so definitely this is going to my root. Okay, so I'm going to create one root first. Okay, I have created this root. Done. Now I'm going to move my I forward. Okay, my I moves forward here. So here this root, okay, this value is not equal to this value, right? So if this is the case, right, so if my pre-order and post-order, okay, both the indexes are matching first, okay, so we have to just return that only, right? 1 and 1. So that simply means one node, right? Okay, so if this index 0 index is matching with this one, so we have to stop now. Okay, so now here 2, okay, 1 is my root. Okay, and now my I is at this particular position. Okay, so see this, for pre, first we are covering the left part. Okay, root is done. Now we are going to cover left part. Okay, so in the left part, I'm going to write this 2. Okay, this 2 is done, right? Now my 2 is going to move forward. Okay, and my I is going to move forward. My I reaches here. Okay, so now this 2 is not equal to this P. Okay, this value 2 is not equal to 4. Okay, I moved I here, but I'm checking previous root. Okay, this root is not equal to this. All right, so now for 2 I can write my left part. Okay, again, because here I told you na, root, then this left. For this left, this is root and then left. Okay, so that's a simple meaning. Okay, now I'm going to write 4 here. Okay, now I'm going to move my I to the next index. Okay, so now is the important step. Okay, now see here, this 4 is the root. Okay, and this 4 is in the post. Okay, this P is here and this was the root. Okay, this 4 was the root and this is the P. Okay, so now what does this mean? So in the post we have the leftmost element first. Okay, left node first. Okay, the left. So this left. Okay, here, right? This is starting from here. So for this particular node there are no other left and right? So now what I have to do, that simply means that there is no left and right for this. Okay, because my P is at this position and this 4 is matching with this P. That simply means that there are no child for this 4. Okay, that is the simple meaning of this. Okay, so now this is done. Now what I have to do, I have to move my P to the next index. Okay, P here. So for this 4 we are done with everything. Okay, there is no left for this, there is no right for this. Okay, so now I move to the top position. Okay, so here but we have 2. Okay, so in the pre we are going to solve first root and left is done. Okay, for this root, okay, for this root left is done. Now we have to cover the right part. Okay, so in the right part, if you see, root is 2. Okay, this is the root. Okay, we move back, right? So this 2, right, we have to solve the back process, right? For this 2 we have already solved the left part. Now we have to solve the right part. Okay, so this 2, okay, this 2 is not matching with this 5, right? It's not matching, right? So here we are, right? Okay, so now my I, okay, my I is at this position, right? But my root is this. Okay, for this root, okay, this root is not matching with this 5. So what I'm going to do, I'm going to add 5 here. Okay, done. I was just checking the root. Okay, so 4 I have checked. Now I was checking with this 5. Okay, so now 5 is done. Okay, I have added 5. Now my I is going to move forward. My I is going to move forward. Now for this 5 I'm going to check left and right. So here see, this 5 is the root and here P both are matching. Okay, so this 5 and this both are matching. So what we need to do, what does this mean? That there are no left and no right for this. Okay, because in the post order we have left, right and root. Okay, so this is done. Okay, this is done. Now right is done. Now we come to the root. Okay, then for this complete, we have solved this complete left. Okay, now we have to solve the right. Okay, right of this. Okay, so now after that what we need to do, here 3. Okay, so in the pre, okay, 3 is here. All right, so now we are moving to the right part. Okay, right part. So here I can use this 3. Okay, then I'm going to move forward. Okay, my I is going to move forward. all right, and here also my p is going to move forward. Okay, when I check that for p, for this 5 there are no left and right. Okay, since we reach the end element, so here I'm going to move the b to this. Okay, now for this 3 again we are going to check. Okay, 3 I've added, my I is going to move further. So for this 3, 3 is a root. Okay, this is matching with 2, no, so just do one thing here, add 6. Okay, and then you can move I to the next position. Okay, your I moves here, then here you can add 7 here. Okay, to the left part. Okay, in the left only we can scroll. Okay, so you can construct any binary tree. Okay, if there exist multiple answers, so this is also going to give you the correct output. Okay, so this is a same thing that we have to do. All right, so this traversal is important here. So how we are covering first root and then left and then right. Okay, so this is the thing that you should know, okay, for solving this problem. All right, so now I'm going to write the same story whatever I have explained here. So let's move to the coding part. Okay, so here first thing that you need to do here, create the index. Okay, so I'm going to create the index here only, private int pre-index. Okay, I'm going to set it to 0. Now private int post index and set it to 0. All right, both are set to 0, and then after that from here I'm just going to simply return construct tree. All right, and here I'm just going to pass my pre-order array and post-order array. Okay, this is done. All right, now once this is done, then after that just create one helper function to recursively build the tree. Okay, so here private tree node. Now here construct tree. Okay, and here what you need to do, you have to pass the pre-order, and here just pass the post-order, order. Okay, now this is done. Then after that what you need to do, now we have to create a new node with the value at the current pre-order index. Okay, so that is going to be my root. Okay, first starting from here. Okay, so now understand it carefully from here. Okay, so now tree node root is equal to new tree node, and what is the value that I'm going to pass? So from my pre-order array I'm going to pass the value which is at pre-index. Okay, right, so this is the value I am passing first. Okay, so here I am passing this 1. Okay, then I have to move my index to the next position, right? So here I'm just going to do plus plus. Okay, this is clear, right? Until here it's clear. Okay, this is done. Now we have to check the left subtree and right subtree for this. Okay, so we have to recursively construct the left subtree if the root is not the last of the its subtree. Okay, so here I will check if root dot val. So what we were checking, my I was moving forward, but we are checking this one, right? So if root dot val, so I have stored this value in the root now. So here I'm checking if root dot val, okay, if it is not equal to post order, and here I'm just going to pass post index. Okay, if this is not equal to this, then we have to construct the left subtree. Okay, so in the left subtree again I'm just going to pass this. Okay, so here I'm just going to write root dot left is equal to, again calling this. Okay, and you know that this pre-order and post-order I have defined here, so it was incrementing here only. Okay, I'm not passing the indexing is automatically incremented. Okay, so this is for the left subtree. Now same way we have to check for the right subtree. Okay, if root dot val is not equal to post order or post index, then root dot right. Okay, so here for right we have to solve. Okay, this is done, right? First we are checking for the left. Okay, so this is the simple, right? So in the pre-order first we are root, then left and right. Okay, so I'm checking for both left and right. And okay, so here if you see root dot val is not equal to my this 4. Okay, initially here my post index was here. Okay, so it was not, so I am adding 2 here. Then 2, for 2 I am checking, so I am adding 4 here. Okay, then my I reaches here. Then 4, after adding 4, my I moves here. Then 4 I see that this is matching with this one. Okay, so when my root.val matching with the post order post index, okay, so this will not be executed. My root.val is also not matching with this, then this will not be executed. Then after that I am just incrementing the post index, right? Post index plus. Okay, I'm just incrementing the post index, right? So after incrementing the post index, so I have solved this part. uh, I have solved this. Okay, for this. Okay, solved it. Now for this is pending now, so now I have to check this. Okay, so 2 is the root. Okay, if I backtrack, then this 2 is going to root. Okay, so for this root I will check if this is matching with the p. No, it is not matching, then I will add 5. Okay, so that's simple meaning. And once this all this is done, then we have to return root. That's it. Okay, so easy. All right, so now let's run it and see if the any code issue. We'll try to fix that. So yes, so here spelling mistake. Let's run it again. So again somewhere spelling mistake. So here I is capital now, so yeah, increment. Okay, I is capital, pre-index. All right, capital letter. Okay, anything else? Here line number 9. So this is what we have fixed, right? Okay, let's run it. Line 12, what is the issue? Okay, here post order. Okay, post order. Okay, so this is small, like O is small. Here also O is small, and also it's small. Okay, and okay. Let's run it again. Okay, all the test cases have been accepted. Now let's submit it. So see, our solution is accepted, and the time capacity for this problem is going to be O of n. So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.